I guess too much of my face today, so I don't watch me on my mirror in the next 3, 4 days because that was enough. But anyway, thank everybody to stay here to talk more about NoSQL database. I know this morning I talked about buzzwords, but it's hard to resist around buzzwords. So today we're going to explore this a little bit more with NoSQL Endgame, where the idea is, okay, we need to work with NoSQL database. We need to know what is NoSQL database as solution. As any kind of solution, it has trade-off. There's no silver bullets, right? And given that, each Java frameworks fit better on your case. We don't believe in silver bullets, but in this case, we're going to make a exception, talk more about Jakarta. I'm kidding. So my name is Otavio.
Yeah, I'm Werner Keil. I run my own company, and I help a client in the public sector right now with cloud native. So the next talk, which is actually in here, is pretty close to what we are doing right now. But we also work with NoSQL databases, and that's what we're going to talk about right now. So what are the top trends in this year and for the last couple of years? More and more customers are going online. The internet is ubiquitous and almost everywhere. Big data keeps getting bigger and bigger. And of course, everything moves into the cloud, or it becomes mobile, or a combination of both. So these new trends obviously create some technical challenges. And let's have a look at what are some of these challenges. First, most projects are run agile nowadays. Who does not do agile? High performance and high availability is important. Somehow. Yeah, it works. It was just a little delayed. And you need to manage huge volumes of data. So where does NoSQL come into play? It handles large volumes of data at high speed. It allows to store both unstructured, semi-structured, or structured data. The schemas are easier to update than, for example, in traditional relational databases, where you may have to completely take down the database and set it up again if a field changes or a field length changes. And it's usually developer-friendly. For example, some of the formats use JSON that you're also used to exchanging data from REST APIs. So it's usually well known, and in some cases, that's exactly how the objects are stored in the database. And it takes advantage of the cloud, allowing almost zero downtime. So why this talk? Yeah, as Otavio already mentioned, there are lots of different frameworks, and we're going to look at them very briefly. Normally, this would take a whole day or a workshop, but we are trying to fit this into a 1-hour talk. The JVM can cope with heavy loads. There are many persistence frameworks. We are going to pick out the ones that you see on the right-hand side. Which of them performs better for your case? Yeah, normally this will take a whole day or week to compare, but we're going to squeeze this into a single talk, showing you the most important features of each of these. So just in case, GORM is probably a little less familiar, but it has highly influenced Micronaut Data. Then there's Spring Data, Jakarta EE with the Jakarta specs, Jakarta NoSQL and Jakarta Data, and Quarkus. So there are lots of different databases. Not all of them use a structure. NoSQL usually doesn't have transactions. It's centered around base, and there are 4 major types. The first one is key value with Amazon Dynamo, S3, Redis, or Hazelcast. The second type is column-oriented, so that's actually relatively close to traditional relational databases with HBase, Cassandra, SimpleDB, or DynamoDB. Then there are document store-based solutions like CouchDB or MongoDB. Graph databases like Neo4j or HyperGraphDB, they actually allow sometimes more sophisticated relations. And while it's technically similar to the others, but there are also databases that are time-based with time series where you can, almost like the Avengers, go back in time and look at a particular point in time in your data. And then there are multi-model solutions that combine 2 or more different types. For example, OrientDB supports both graph and document. Couchbase does key value and document. ArangoDB actually supports up to 3 different models, or Elasticsearch, which combines document and graph. So how do you compare SQL and NoSQL databases? First of all, yeah, there are lots of buzzwords and acronyms. In SQL, you have table, row, column, and relationships. In key value, you have a bucket and a key value pair. Column is a little closer to the traditional SQL. In documents, you have a collection, a document, a key value pair, and a link. And in graph, you have even more sophisticated terms like the vertex and edge properties. Then there's the principles of ACID, atomicity, consistency, isolation, and durability, while NoSQL databases follow the base principle, basically available, soft state, and eventual consistency. There's a description called CAP, where you look at consistency, availability, and partition tolerance with various solutions like SQL databases like MySQL, MongoDB, or Redis, as well as Cassandra. And you can look at them from a scalability versus complexity point of view. Again, the 4, or actually time-based databases would also be somewhere close to graph, where key value is very scalable.
You're welcome.
While graph can be very complex. So you have to look at which solution and which type of NoSQL databases fit your particular needs best. In the JPA and relational world, you would usually have a DAO tier and then access your database using standards like Jakarta persistence on top of JDBC, which is then connected to your actual database. In NoSQL, you would normally have lots of different APIs by different vendors, making it harder to switch from one to the other. And that's why an abstraction layer and some sort of standardization can be helpful. So we are looking at Quarkus with Hibernate Panache under the hood with NoSQL support. We have Hibernate Micronaut Data and Spring Data, as well as Jakarta EE with the combination of Jakarta Data and Jakarta NoSQL. I will briefly brush GORM, but since GORM has heavily influenced Micronaut Data, unless you're working in a legacy application where you need to access NoSQL data that's written in Groovy, for example, usually it's probably better to use Micronaut Data and not start using GORM. But if you have a legacy database and you need to support NoSQL, then of course GORM might also help. What are some of the problems that JPA has using NoSQL databases? Actually, in earlier versions of the slide, we also mentioned Hibernate OGM, which tried to map the traditional JPA model onto NoSQL databases, but nowadays this is practically unmaintained, and if you want to use NoSQL databases in the Quarkus and Red Hat world, then it's usually better to use Panache, as is also mentioned in the slides, and if we have enough time, I can show you a quick demo of it, while Hibernate OGM is completely unmaintained now, I think since 2018 or so. So unless you have a project where this was used and you still need to maintain it, I would not really look at it nowadays. So the saves are usually asynchronous. The consistency level is different from JPA databases. Yeah, and usually you have a large diversity in NoSQL. That's where SQL doesn't always fit in well. So how do most of the frameworks in the Java world approach this? By annotated entities. Here we have an example for Jakarta NoSQL, or actually, I think that the entity may even be moving into Jakarta Data, but in general, you have annotations, and that feel relatively close to what you may have already worked with when you dealt with JPA. Some of them have template support, for example, Jakarta NoSQL or Spring Data. All of them support the repository pattern. Now let's look at some of the concrete examples. So Micronaut actually started supporting NoSQL quite some while ago. But the Micronaut Data framework is a little younger and is also, in some cases, still actively developed. Therefore, it has support for some popular NoSQL databases, but it doesn't support that many out of the box yet. But for example, it supports MongoDB and Neo4j, and I believe Cassandra. So the ones that are really widely popular, you'll find support, but you may have a slightly harder time if you use something that's a little more out of order and a little more exotic. Again, Micronaut Data uses annotated entities, like in this case. And in fact, Micronaut Data is also the creators and contributors to Micronaut Data also participate in the Jakarta Data project. So over time, some of these frameworks, especially Micronaut Data, are quite likely to support the common standard that Otavio will tell you a little more in a few moments. It supports entity annotations. You can do query by text. So that's a little bit like having SQL statements in JPA. Then again, very briefly, because it largely influenced Micronaut Data, and it was also created by the same people who are now behind Micronaut and Micronaut Data. So in GORM, this looked quite similar. So now let's look at Spring Data. So again, the annotation for an entity. Then you have a repository. And what about the controller? The controller is usually just some glue, and that works relatively easy. And in this case, we are using Spring Boot. So Spring Boot supports most of that boilerplate code, and you have very little actual code to write. So in most cases, your application consists of some vital classes like your entity and the repository. Here in this example, for Neo4j, you see the relationships in a graph database. For example, a movie like Forrest Gump, and a person can have more than one type of relationship. Here you would have Tom Hanks, who acted in that movie, and Robert Zemeckis, who directed it. And that's, aside from Spring Boot, Spring Boot has all those starters, so that's pretty much all you need in your POM to make it work with Neo4j. Then a little bit of configuration. And that's what you need in your actual code. Again, having a movie entity, a movie repository, and a person entity. Here's how the repository looks like. Here's the entity. As well as the other entity for the movies. And this is how the relationships can be modeled using Neo4j support in Spring Data. So next is Quarkus. Again, Quarkus supports an extension or evolution to Hibernate called Hibernate Panache, where you also have both traditional and reactive ways to access your database. So it's a little similar to what you can do with either Jakarta Data or Spring Data. And then aside from the entity, you have a repository. Both use CDI here, for example. That's also some similar to Jakarta NoSQL. And yeah, we may show a few live code samples towards the end, but now over to
Yes, I can do
Otavio.
some live code. Uh, okay, as you see, we have several solutions around NoSQL database in Java, right? So, and guess what? When we talk about NoSQL, okay, let's one step back. When we talk about SQL, we just have one single solution or one single way to solve it, right? Because if you are a Java developer, we know how to use JDBC and then JPA, and this one will be the regular API. So if I decide to switch between MySQL and Postgres, theoretically, it's not safe. It will be easier to switch between these if without impact the API. But when I talk about NoSQL, we need to understand first, there is no standard yet. Second, we have over 400 NoSQL database. Wonderful, right? So this one here is just one case. As you can see here, I have 4 different NoSQL database: ArongDB, MongoDB, Couchbase, and OrangeDB. Imagine that you can see that because it's even hard to me see close like this. But basically, what these 4 different APIs is trying to do is exactly the same thing. So I have my name, I have my value, and I want to insert that information directly inside my database. My first question is why? Why do I need to learn new different APIs to do exactly the same thing? Why did you memorize to do with ArongDB, with MongoDB, with Couchbase, OrangeDB, the exactly same thing? That is the main idea around the specification, to make easier to you go cross NoSQL database. The idea is not to fight between vendor lock-in, because let's face it, once we did with MongoDB, what's the chance that you want to switch between database? I mean, your foundation is in MongoDB. I believe it'll be really, really hard to switch between NoSQL database like we did or we are already doing with SQL. I mean, I have application of 10 years of MySQL. I cannot imagine the possibility to switch to another SQL database just to have fun. Okay? So that's the idea, to make easier for me to decrease the complexity. So basically, what I'm doing here is I'm injecting the template. So it's a template injection. If you are a Spring developer, don't worry. You can imagine right now auto-riot. And then I'm doing several operations. So I'm inserting some books. And then I did a select with Fluent API. The idea is, okay, each database I'm using, the answer is, I don't care, because I'm going to use the same API to reduce my cognitive load to handle with NoSQL database. Right now, I could use OrangeDB, I could use ArongDB, I could use MongoDB and Couchbase using the same API. And that's the idea, to make it easier. Another point to decrease the complexity load around the specification is to try to use what we already have in the specification words. Of course, if you are familiar with Java and SQL, you know that, okay, I want to define an entity. You're probably going to use entity annotation with JPA, right? You're going to define the ID with the ID annotation because you don't have enough imagination to put another thing. And to define a column, the column annotation. How hard is it? So that is the idea. And by the way, we have support with records. Why? Because you love buzzwords. Everybody's talking about records. Why not have support to that? So that is the main goal, to make it easier for you. So you know how to decrease the complexity. Sorry, I will try to make me more beautiful between the cameras to show to my mom. But anyway, The goal is to decrease the complexity. So it looks like entity, or it looks like JPA, but it's not. It's Jakarta NoSQL specification, especially because the entity and the ID and the column is agnostic from database. You don't care if you're going to use MySQL, you might have an ID. If you're going to use Cassandra, you might have an ID. If you're going to use Redis, you might have an ID. Okay? Of course, the modeling will be a little bit different. However, the idea is the same. And that's exactly what we're doing with the specification words. Make it easier to the Java developer interact with NoSQL database, exactly like we are doing here. So I have my person entity where I have my entity to define the annotation, to define this class will be persistable. Then I have the ID and then the columns. And basically, based on this annotation, I can convert to column family, document, graph, and key value. So one API, too many NoSQL database. Do you catch the joke? One too many, NoSQL. It was a bad one, I know. I don't judge you to don't like it. But what I can see here is the template. I'm injecting and I do a couple of operations to make my life easier. So you're probably not able to see here, so use your imagination like it's blind mind moment. So I'm injecting my template, and then I'm doing some operation with my Ferrari car. Then I find by ID, where I'm returning the optional, as you can see, because this API was built on Java 8 or higher. Right now, we are setting Java 17 as the latest LTS. And the idea is to, okay, why not use optional to avoid null pointer exception? So you can validate before you use, especially because my ID is 1, so it might return some information or not. So to make sure that I won't get a null pointer exception, you can use optional. We are doing the select here, as you can see, select where, and we are exploring the power of the Fluent API. So if you are familiar with Jock, it's exactly the same idea. So we took some feedbacks from Hibernate session, move here, however, we put more Fluent. And we are doing exactly the same thing here with the delete method. So delete car where ID equals 1 and then execute. So I mentioned the template because it is the highest API. However, each NoSQL database has particular behaviors that we want to use, that we want to explore, right? I mean, if I'm using Cassandra, of course, I love to use Cassandra query language. If I'm using MongoDB, of course, I want to crash and product. No, that's not. If I'm in MongoDB, I want to use particular behavior of MongoDB. So that's exactly the idea of specification. I have the template that is the highest level of the interface, and then I have more specializations, like key value template to work, of course, with key value, graph to work with graph, document to work with document, and column to work with, of course, column. And you have more specialization, like I mentioned to you. So key value template has my vendor template, for example, Hazelcast has index to the key value information. So the idea is to pull that information over here. I guess we're going to have a little bit time to do live code, hopefully. And besides that, we also have Jakarta Data. And the idea is like the DDD approach. So I have my repository. I have my entity with my business layer here, with my domain. And then I have my entity in my repository. And then you ask, wait, where does data come from? I have no idea. I don't care, because we need to handle only with the interface. So it might come from the REST API, from JPA, NoSQL, or whatever your imagination wish for. This is a sample of repository from Jakarta Data. If you are a Spring developer, it sounds familiar for you, right? Or if you are a Micronaut developer, it sounds familiar for you. Especially because on the specification words, one thing that we love to do is use what we have already in the market and bring our specification. Why? Because we are lazy. I don't like to try to innovate so much. So I wait to Spring do something wonderful and then bring to the specification world, especially because they can try, they can break. For example, they did a lot of experiments in the Spring 1.1 version, Spring Data 1.1 version, where they break completely in the version 2.0. And based on that experience, we built this repository where you can also handle with method by query on, exactly like we did with Spring. So if you ask me where did you get those ideas, Spring was, for me, the huge inspiration to handle this kind of thing. So that's why we have the CRUD repository. Of course, we also have the support to work with pagination right now. The idea is to release those specifications in Jakarta E11, right? Hopefully.
Hopefully, yeah.
You know software, maybe delay it, not. So please don't judge me. Sometimes delay some things, like Java. But anyway, the idea is exactly the same. So we have the repository here. That's supposed to be garage because the collection of car could be garage. However, nobody cares. They usually use repository at the end. And I'm injecting, and then I'm doing some operation, and then I have my save method here. So right now, if you ask me, where this data is coming from, I don't care. It might come from MongoDB. It might come from Cassandra. It might come from whatever you want, even from SQL database, API. So the point is, your application is saved from these database implementation details to focus more on the business details. Okay? So as I mentioned, we have the CRUD repository to handle with the basic operation, but of course, it doesn't make sense to handle with a huge amount if without pagination. And to handle that, we also have this pageable repository interface where I have my products as type exactly like Spring Data does, and my long as an ID, and then I could do my query. In this case, find by type or the by name, where I'm inputting the type, and I'm doing the pagination through this method here. So I'm returning the page where I can get the page number 1, page number 2, number 3, and define the size of the page and the page number. Okay? That is. No? You don't like it? Me neither, sorry. And of course, when we talk about NoSQL database, we need to pay attention on diversity that we have. Because, as I said before, NoSQL database leads with a huge amount of particular behavior that we'd like to use, or you'd love to use, or even more, we need to use on production, like Cassandra. It doesn't make sense that I do have Cassandra and don't use UDT, that is user-defined type. It doesn't make sense at all. I mean, if I'm using Cassandra, of course I want to use CQL, that is Cassandra Query Language. So the API itself allows you to use the power of particular behaviors, like I'm using my God. Okay, it sounds weird. My entity, that's called God, where I have several informations, and then I'm able to do the query. So select star from God where name equals name, where I'm informing the query and then the first parameter, exactly like that. And if you're familiar with Cassandra, you know that you usually can do query by the ID or secondary index. So there are a couple information that you can use and explore. For example, on Cassandra, you can define the consistency level of the query. So I want to query in my node of 3 server instance instead of go to the whole server instance, and so on. Of course, we have query, but one important point here is each vendor might have a different type of query. Why I'm saying that? Because if you do query with MongoDB, might have a different syntax. If you do query with SQL, you are able to use joins. If you do query with NoSQL database, you don't have, of course, SQL. You're not able to do joins or things like that. So each NoSQL database might have a different type of query, different type of syntax. But the whole point here is when you inject and do the query, you don't need to change the methods, the client itself. You only need to change the query that is on the person repository. If you eventually decide to switch between database, you need to change over here only, and not anything else. That is the idea of the specification itself to make our life as a developer easier, to decrease the complexity. Okay, right now, I don't need to memorize 400 NoSQL database types APIs. I just need to memorize just one. Based on that, I can use regular NoSQL database. And of course, if I want to use any particular behavior, I can extend the API using and explore the power of polymorphism to make it possible. About the conclusions, wow, it's wonderful. Perfect. This is Micronaut, right?
Yep.
So it is still in progress solution, so you mostly have support to SQL database. But if you want to use MongoDB, for example, you're going to have a few support, but most of the time you need to do everything manually. You need to do the conversion manually. You don't have like a fancy interface like we do in the specification itself. And Micronaut Data only has support to, as far I know, MongoDB. So I want to use Cassandra. Oops. Do it manually. Sorry for you, guy. However, it's really fast because you can explore the power of GraalVM to compile things, to avoid to use reflection, for example. On the other hand, we have GORM. So I can go faster because nobody cares about Groove anymore, right? So I will skip this one here. And Spring, for me, Spring is a more mature solution when you talk about NoSQL database. I mean, it will remove a lot of boilerplates. If you ask me, okay, my finance area knows a lot of Spring, and I want to use NoSQL database, there's no way. My recommendation will be, please use Spring Data MongoDB. It's provided a cleaner and more readable DAO implementation. However, if you wish, you can use it even more. You can use the repository with that. And you can switch almost easily between vendors. So if you use repository approach, you can switch between MongoDB with Couchbase and so on. However, it has less support. So right now they have around 6, 7 NoSQL database, as far I know, but they're still in progress. The Quarkus is a Red Hat solution. It removes a lot of boilerplates, but it's not easy to switch between NoSQL database because each one has your own interface, one way to handle, and things like that. If you want to use MongoDB, you will need to use Quarkus with the MongoDB API itself. The same thing happened with Cassandra. If you want to use Cassandra with Quarkus, you need to basically do it almost manually. So it's a lot of boilerplate. And we talk about code. More code also means more bugs and more things to test, more things to document it. And can be faster with GraalVM option, of course. But if you put bug in production, I kind of don't like it. So, and the last one is the one that you enjoy more because Spring does not provide sticker for you, and Jakarta do. So it's still in progress. The idea is to remove boilerplate and provide a cleaner and more accessible data access object, and also repository. And to prove that it's still in progress, as you can see here, the logo is wrong, right? So it's supposed to be here. So even the presentation is still in progress. So, but the good news is, I mean, even in the version number 6, right now we have support to over 32, 35 NoSQL database. So it's a huge amount of NoSQL database, even to a new baby specification implementation. Mostly thank you to the Graph database, because we are supporting Apache Tinkerpop, and based on that, we receive for free 25 NoSQL database, and we have support to at least the most popular one. So if you want to use MongoDB, you have support for it, Cassandra, Redis, and Neo4j, and so on. So ArangoDB and a lot of NoSQL database. And I don't like this conclusion here, because the loads of couple to switch between NoSQL database. As I mentioned to you, it might happen, but it's really hard to happen. In my opinion, we could switch this approach to, okay, I don't need to learn a new API every time that I decide to switch NoSQL database. Because when you have a huge team over 100, the solution is important, it is important, but the knowledge inside the team is also crucial. Because if I switch to one thing that just one person knows, it's a dangerous situation, right? Because if this person decides to leave the organization, and something goes wrong when he left, and that usually happens, you are in trouble as an organization. So this way now, you are able to learn one API, and based on that API, you can operate different kind of NoSQL database. Plus, you have the diversity to extend, like I mentioned, with Cassandra, MongoDB, and so on. We have a couple of repositories here. Of course, we don't have time. I guess we are almost over the time. But we're going to show the presentation with slide on the social media. But you can see the comparison between them, see the APIs, to analyze these APIs, to see the difference. You can see the JNOSQL.org, that is the specification, implementation, and then the specification itself, Jakarta NoSQL and Jakarta Data. And of course, as any kind of specification, the idea is to Jakarta has support for it, but also Spring has support for it, and Micronaut has support for it, and even the NoSQL vendors have support for it. The idea is to standardize like we did exactly with JPA, like we did with servlets, GSP, and things that we don't love, but we need to work, right? So that's the idea. So some credits here to Flaticon, that I have no idea, Mike Simmons, Jen Tessier, and Theodore Bias. He might have some bias in some choose. But anyway, I guess we have just 5 minutes left. Thank you. If you have any questions, please let me know. And furthermore, we have more stickers for free to you. Leave the room saying Jakarta NoSQL is the best solution to NoSQL database. And that is it. Thank you.